All right, we're going to talk about rational numbers today. So the set of rational numbers is numbers which can be expressed in the form a over b, so that fraction, where a and b are elements of the integers and b does not equal 0. A is called the numerator, b is called the denominator. So the next thing is we want to have this idea of equivalent fractions. So if I have a fraction here that is a times c over b times c, that's going to equal a over b. What's going to happen is we're going to actually cancel out that c over c because it's going to be, so we put this as c over c, this equals 1, so this becomes a over b times 1, which is a over b. Kind of think of it as just canceling out. So we're going to actually look at reducing this. Now, when we reduce, sometimes it's really nice, we can kind of see what there is to reduce by. Sometimes we can't. And so the way I'm going to show you how to reduce is actually by looking at the factors of these. So I'm going to come here and I'm going to go 130, and I'm going to break this up into factors. And I know that this is 13 times 10, and then 10 becomes 2 times 5. So 130 is 2 times 5 times 13. And I'm going to do the same thing with 455. Okay? Now, I may not know a lot of what goes in 455, but I can see that 5 goes into it. And this gives me 91. And then I look at that and I think, well, is 91 prime? So 91 is not prime. It becomes 7 times 13. So now I have 5 times 7 times 13. And what's going to happen is notice that if I have the same value on top as in the numerators I do in the denominator, they technically cancel out. So this becomes 2 sevenths times 5 over 5 times 13 over 13. Those become 1, which gives me 2 sevenths. Okay? So 130 over 455 will reduce to 2 sevenths. So we have two types of numbers here in our fractions. We have a mixed number, which is a whole number or an integer plus a fraction. So this is 3 4/5, and we could write that as an improper fraction. So to do that, what I'm going to do is to get this to be an improper fraction, I'm going to take and multiply my integer by my denominator. So 3 times 5 is 15. 15 plus 4 is 19. So this becomes 19 over 5. All right. So depending on what you're doing will depend on whether you want to write it as a mixed number or an improper. A lot of times cooking, we write in mixed numbers a lot. We don't write it as an improper fraction. We don't say, 3 3/4 of, we say 3 3/4 of a cup. We don't say 15 fourths cups. It just doesn't work. So what we're going to do is now we're going to convert from improper fraction to a mixed number. So what I'm going to do is I'm actually going to divide that out. Okay? And 5 goes into 42 8 times. This gives me 40. This is 2. 5 does not go into 2, so there's my remainder. So this becomes 8 2/5. Okay? Now, if I'm going to convert to a decimal, I'm going to actually physically divide these out. I know a lot of you will have a calculator to work these out, but we're going to work it out by hand. So what I'm going to do is I'm going to put my decimal in here, and then I'm going to put a couple of placeholder zeros in here. I may not need all of them, and I probably should start with 1 and then add another, but 8 goes into 50 6 times. So I'm going to put my decimal here, so now I know it's 0.6. That gives me 4.8. This gives me 20. 8 goes into 22 times. That gives me 16. That gives me 40. 8 goes into 45. So the equivalent decimal to this is 0.625. So I just divided it out. Now we're going to talk about converting from a fraction to convert from a decimal to a fraction. So if I have here, if I have one decimal point, I'm going to put that as 7/10. And then I would reduce accordingly. So now I have two decimal places, so I have to have two zeros. So this becomes 49/100, reduce accordingly. Now that's nice if our decimal is terminating, then we can just kind of put the decimal over one with how many decimal places there are, that many zeros. But what happens if I have a repeating number? So if I have a repeating number, I'm going to start off with my repeating number. So in this case, it's 0.6. So what I'm going to do is I'm going to set n to be that repeating number. So 0.6666666 repeating, okay? Now, I'm going to multiply this by 10. In this example here, I'm going to multiply this by 10. The reason is I have one repeating decimal, okay? So how many decimal points are repeating? That's how many zeros I'm going to have in my multiplier. So I end up with 10n equals 6.6666 repeating. And then I need to get rid of this 0.6 repeating. Well, that's subtracting off one n. So I'm going to subtract off one n from both sides. On the left side, I'm going to use n. On the right side, I'm going to use its equivalent, which is 0.666 repeating, which gives me 9n equals 6. I'm then going to divide by 9. I get 6/9, which reduces to 2/3. Now, here I have more decimal points repeating. So I have 0.53 repeating. And so I just rewrote this. I said n is equal to 0.53 repeating. So I just had this repeating item here. Now I have two decimal points. So what I'm going to do is I'm going to multiply everything by 100. So I'm going to multiply n by 100 and 0.53 repeating by 100. So I get 100n equals 53.53 repeating. I got to subtract off the repeating part. So I'm going to subtract off the 0.53 repeating, which is subtracting off 1n, which gives me 99n equals 53. Divide by 99. That gives me n equals 53/99. There's my fraction of 53 repeating. So we're going to quickly just go over how to multiply, divide, add, and subtract with fractions. This is, if I was looking at, so we need all this to talk about how do I handle when I have to double a recipe or something like that. So if I'm multiplying here, so what's going to happen is I'm actually just going to multiply straight across. So multiplying is nice because I just go 3 times 5. That gives me 15. 8 times 11 is 88. There's my new fraction. Now when I divide, what's going to happen is whatever fraction I'm dividing by, I'm actually going to multiply by its reciprocal. So I'm going to go 4 over 5 times, now I have to multiply by the reciprocal, 10/1. Well, I'm going to do a little bit of reducing now instead of multiplying it out. It doesn't really matter. I'll show you both ways. So one way, I'm going to put it up here, is to multiply this all out. 40/5, which reduces to 8. Another way is 5 goes into 10, 2. 4 times 2 is 8. 1 times 1 is 1. I don't have to put 8/1. Okay? Now, when we're adding and subtracting, okay, we have to have a common denominator. So the first thing we need to do is find that common denominator. Okay? So I have 4 and 6. One of the easiest ways to find a common denominator is you can actually just multiply these together. That's not the least common denominator. It'll get you a denominator. I'm going to find the least common denominator before 4 and 6. The least common denominator is 12. So I know both of these numbers go into 12. So I'm going to multiply 3/4 times 3/3 because I need to get this to be a 12. Okay? That means I have to multiply top and bottom by the same amount. So I'm not actually changing the value because when I multiply by 1, I don't change its value. Plus, how do I get 6 to be 12? I multiply by 2. So this becomes 2/2, which gives me 9/12 plus 2/12. Now I can add these together. I'm going to add the top numbers and get 11/12. 12. So the bottom number stays the same in addition and multiplication, addition and subtraction. Okay. Now this one's a little bit trickier because they have commonality in here. So 15 and 24. So this is really 3 times 5, and this is really 3 times 8. So I notice they both have a 3. So I could multiply this by 8 over 8 because I'm just missing the 8 here. So if I multiply this by 8, so I have 1/15 times 8 over 8 minus, now this one's missing the 5. So 7/24 times 5 over 5. Okay, so that's going to give me 8 over 120 minus 35 over 120 is going to give me negative 27 over 120. Now, when we're looking at these, we want to make sure that we can reduce these down. So we want to look here. This becomes negative 9 times 3. This becomes 40 times 3. 3's cancel out. I get negative 9 over 40 is my reduced amount. So when we're looking at doubling these, okay, so if I have a fraction and I wanted to double it, I would multiply the numerator by 2. If I have a mixed number, I'm going to double the whole number and double the numerator. So that's dealing with rational numbers.